Hi guys, please like, share and subscribe. And if you want full course for any actuarial subject, visit theactuarialguy.com or WhatsApp on this number. Thank you. Hello and welcome guys. In this lecture, we are starting our discussion with talking about how to manage your workflow within R. So in the last lecture, I had solved these two puzzle questions and saved their scripts in one particular folder that I had called R programming lessons, which was located inside my documents folder, right? So a lot of times in reality, in your real world data science projects, you will have many scripts related to one project, okay? Within a project itself, you might have to clean your data, build your model, validate your model, and each one will have a separate R script, right? So you would want to structure them in a very intuitive way, right? So how do you do that within R is what we are going to talk about, and we are also going to discuss some of the functionality that R offers in terms of managing your workflows and also recovering data from previous R sessions and all of that, right? So let's talk about that. Let's get into that. So firstly, let's talk about a few concepts and terms here that are relevant. First one is session. So a session in R is the time period between the opening and closing of R. So in the previous lecture, uh, all of my code that I had written was after opening R and I closed it after I ended writing that code. So that was a separate session, and today I will be starting with a new session of R. Once you close R, the next time you open it, a new session opens, and every time you close it, R will give you a pop-up that do you want to save all the data from this session. Now what kind of data do you have in one session? You have something called as a workspace, right? Workspace is basically the working memory of the current session of R. You can think about it as the random access memory, whatever is saved with respect to uh, the current session, all the objects you have created, right? All the variables that you have assigned value to would be stored in your working memory, that is your workspace, right? And this workspace you can choose to save in an image, so the next time you open R you will recover all of those variables that you had assigned in the previous session. You won't need to run the code again, okay? Next is the concept of working directory. So working directory is basically where is your R code running exactly on your computer, right? Where are all your data files located, right? It's the default folder on your computer where R will look for files to load and where it will save files, right? So whatever you want to load, maybe there are some CSV files, some Excel files that you want to load data from, right? Or you want to save some files, it will directly go to that working directory. So this is very, very important. The first command that I want to discuss in this regard is the get working directory or get wd command. Okay, this just shows you the current working directory path. So how do you do this? Let's just see. So this was my code, and now I will what I'll do is I'll start writing at the bottom of this, or I can write in my console directly. Okay, so I'll type get wd. Okay, and it will show me my working directory, right, which is user slash apple. Now this is a base working directory in my computer, that is it's just uh, my current user for my computer. I would not want this to be the working directory. I would want it to be a particular subfolder for my project. So what I would want to do is I would want to change the working directory. Now how do you change working directory, right? So from this user slash apple, actually I want to change it to user slash apple slash documents. Okay, and within that, what was the name of the folder I was using? R programming lessons. So I would want to use this for my working directory, right? So I want this to be my working directory. So if I want to change it to this, what I need to do is I need to use a command for changing working directory, which is set working directory, set wd. So I'll just use this command and I will set my working directory. Again, you can write these commands in your code, but typically it's better to write these commands directly into the console, because these are typically not a part of your project, but just you ensuring that you are in the right place. Okay, so once I've set this working directory, you would see, and you can actually press the up button in console to get your previous commands, right? So if you will keep on pressing the up key, it will keep on showing you whatever commands you've written before this. So I want to again go to get wd and just run it again, and you see my working directory is now changed to this, right? It also shows here document slash R programming lessons. So this is my new working directory, right? So that's the first thing. Now uh, if you will quit the current session of R will ask you if you want to save uh, the workspace image, that is all the objects, and if you select that you want to save, in your working directory you will have a file called as .rdata, which will contain all these objects, and the history of all of the commands that you have typed out, they will be saved in .r history, right? So both of these things, all of the objects you have created and whatever commands you have typed, would be saved in these, and then you can just see them here. See history, in history I have all of these things, and in environment I have all my objects. Okay, so this is how it works, right? Once we will close this, you will realize that R will ask us if you want to save objects. Let me assign an object, assign a few more objects, and just close this, so to show you that R will ask me that question. Okay, see, now it's asking for two things. One, do you want to save this file, premium calculator, and second, do you want to save your workspace image in .r data file, right? Once you click on save selected, it will save those things, and the next time I will open my R Studio, if I am working in the same working directory, everything will pop up again the same way. All the variables that I had made are just here, right? Nothing has changed. Okay, so that is the idea. Now let's move on. Okay, next thing is a project in R. So as we were discussing, in any data science or actuarial science project, you would have one script to clean data, you would have one script to build the model, another script to validate the model. All of these things combine into one project folder. So how do you create a project in R? You go to file and then you go to new project. Okay, new project, and in new project you can either create it in the existing directory, right? So the project will be associated with the existing directory. I want to create a new directory for this project, right? And I will click, the project type is new project. Okay, the directory name, which will be a subdirectory of my current directory, and this one I'll call cs1_r. Okay, and I will just click on create project. So now a new project is being created, and now I start afresh. My working directory, if you see now, is within that project, within cs1r, right? And any script that I will create now, by default it would be saved within that project, within cs1r. Okay, so that is the idea, it's being saved within cs1r, right? So now I'll call it lecture2.r. Okay, and I will save this. Okay, so this is how you structure your projects, right? Then how do you work with packages? Okay, so see, the thing is that what makes programming languages like R and Python very, very powerful is that they are open source. Okay, which means that anyone can build a functionality on top of R, okay, or on top of Python, and these are built in terms of packages and libraries, right? So what packages or libraries are, these are bundle of related functions, data, etc., and documentation that adds new features to R. Okay, For example, in CS2, I have to work with something called as Markov chains. Okay, when you get to CS2, you will get to know what Markov chains are, right? Or in CS1, I want to work with generalized linear models. Okay, for each one of these functionalities, some people out there have created packages so that you can work with them directly in R, right? So within our curriculum, IFOA and II give us a set of allowed packages. Okay, we have to work with them. So whenever you are uh, writing your exam, you have to ensure that you only use those packages and libraries, and that you have already installed those packages and libraries before you start writing your exam, right? So let me show you how do you work with packages. You have to do two things with respect to packages. Whenever you're working with a new package, it may not be installed on your computer, so you might have to install that, right? Now Python has its own way of doing that. There is something called as pip install in Python, which you have to do within the terminal of your computer. But here for R, we can do it within the interactive development environment within our studio itself. Okay, how do you do that? How do you install a new package? Let's see that. Okay, so in order to do that, you need to go to this menu called as packages, and you need to search for whatever package you want. So sometimes you will find it, sometimes you won't. See, Markov chain is not here. Linear models is also not here. I don't see any package for linear models. So let's try and install Markov chains firstly. So I'll go to install, and I will write the name of the packages separated by spaces or comma in order to install those. So as soon as I'll start writing Markov, I already have a bunch of packages suggested by R. I want to install Markov chain, and I want to install all the dependencies as well. Whatever Markov chain is dependent on, one package can be dependent on other packages as well. And then I want to click install. So what R would do at this point is that it operates through commands only. Okay, so it has actually run this command install.packages, and within this, in quotes, it has put Markov chain. Okay, these double quotes represent a string. Okay, we'll talk about what are the different data types very shortly, but it has indicated to its terminal that the user wants to install this package called as Markov chain. Okay, if it was multiple packages, you could write that with separated with commas, right? So this is how you install. So the benefit of R is that it offers a certain amount of graphical interface as well as certain amount of command interface, right? I could have just written this command and it would have worked, but then, to search through packages, you can use this packages functionality. Or if you remember the name of the package, you can just directly run this command, either by writing it in your script and running it, okay, or uh, you can directly run it in terminal, or the way to install is to just go to install and write the name of the package. Okay, so those are some ways. That is how you install. After installing, you also need to enable the package, right, or load that package into your session, right? So firstly, you can check what are the various packages which are currently enabled in your session, right? And if the package that you need is not enabled, you can actually enable it, right? So in order to check what packages are enabled, the command is search. Okay, if you run search, you would see all the packages that are enabled. So graphics is enabled, tools R studio is enabled, methods is enabled. These are some base packages that are enabled. Most packages are not enabled at this point. So let's say I want to enable a couple of packages. So I want to enable ggplot2. Okay, so in order to enable this, I can just tick and just check this box. And what R would do is it would run this command library ggplot2, and ggplot2 would get enabled. If you run search again, you would see ggplot2 is enabled now, package ggplot2. Okay, similarly, if you want to enable Markov chains, what you can do is either you can search Markov chain and enable it, or you can just type library Markov chain. Okay, and you can just run it. So and now you can check if Markov chain is enabled. Markov chain is also enabled. Okay, so Markov chain or any other package can be enabled this way. And matrix is also enabled because Markov chain required the enablement of matrix, so it also got enabled on its own. Okay, so that is the idea. Now let's try and understand data and object types in R. So firstly, I want to talk about the 5 basic data types in R. Okay, so what are your basic data types? You have numeric, which is used for numbers. This would be real numbers, including decimals, integers, etc. This is the default for numbers, right? They can be of 2 types. One is double, which is floating point numbers, right? Which basically means like with some thing after the decimal, right? Or integer, which is a whole number. Okay, in order to store an integer, you need to write L in front of the number, which would indicate to R that this is an integer which is being saved. We'll see how this works. Okay, next you have character, which is basically text data. This is also known as strings, right? In order to indicate to R that you are storing something as a string, as a character, as textual data, you need to either put it in double quotes or single quotes, right? Both of them work, but both the quotes should be the same. If you're putting double quotes, put double quotes on both sides. If you're putting single quotes, put single quotes on both sides. Okay, then you have logical, which is also called as boolean, right? Which is in all caps, you either write true or false. Okay, this is a data type. This is not a character. True and false in themselves, whether some statement is true or false, in itself is a value. Okay, and for this, T and F are usable shortcuts, but it's best practice to write full true and false, right? So this is also a data type, which is a logical data type, right? Then you have complex numbers, which would be something like 2 plus 3i, right? This is 2 plus 3 iota. Iota is the under root of -1. In the previous lecture, if you remember, I had typed under root of -1 and that had given me a not a number error. So we will see how to work with complex numbers, right? And then if you finally have raw, which is, if you know computers store everything as binary numbers, right? At the back end of the computer, everything is binary numbers. So R also gives us this functionality that you can check everything in binary numbers. What is the binary number for a particular character, a number, so on and so forth, in terms of zeros and ones? You typically don't use this, but this is used in cyber security and cryptography and all of those disciplines. So for now, you don't need to worry about this. This is not a part of our syllabus, but you can just know that there are 5 major data types, right? Now, how do you check if a particular object is of a particular data type? You can use this syntax, which is data type. So you have is numeric, is integer, is character, is logical, right? So you have all of these. So let's try and work with these. So let's just see. So now let me assign a couple of values to certain variables, and then we'll work with them. Okay, so I'm assigning value to A as 5. Okay. Then B, I'm assigning as L5. L5. Remember what L does? L actually converts it into an integer. Okay. Then you have C as 5, but within quotes. Okay. Then you have D, which is true. Then you have E, which is capital F. Okay. This is false itself, right? Then you have F, which is equal to, yes, let's do this. So square root of -1. Okay, this would be iota. Okay, you have G, which is square root of -1 plus 0 iota. Okay, so let's write it this way. Then you have H, which is 0 1 1 0 0 0 1. Okay, yeah, so I have a bunch of these characters. Let me just firstly assign all of these. So I'll just run all of them together. Okay, It's saying L5 is not found. Maybe I need to put a small L. Okay, what was the instruction? Oh yeah, you need to put after. Okay, so this is 5L. Yes, this is how it works. Okay, so now let me run all of them. Yeah, so now all of them are assigned. Now I'll check the type of each one of them. So I will write is uh, dot numeric. Okay, is dot integer, which is also numeric, is dot character. Okay, then I have got is dot logical, then I have got is dot what was the next one, complex. Yes, then I've got is dot, yeah, let's just try with these. Okay, so I'll start with A. Okay, so for A, if you will see, it's numeric, yes. See, 5 is an integer, but it's still not reading it as an integer. Why? Because by default, R takes any number to be a double. Okay, it doesn't take it to be an integer. Okay, so this has come out to be false. The next one is also false. 5 is not a character because we have not written it in double quotes. It's not a logical. Okay, and it's not a complex, right? It's just a numeric double value. Okay, similarly we can do this for all the values. Okay, so what I'll do is I'll one by one replace. Okay, so find and replace, and I can actually replace A with B, A with B. So I'll actually replace bracket A with B, bracket B. Okay, then I'll do it within the selection. So in selection and replace all. Okay, so now let me run this again. So for B, you would see B is an integer. Okay, you would see is integer B is true. Okay, so if you write L after a number, it indicates to R that it's an integer. Okay, let's look at the next one. For C, okay, for C, let's just see. I again want to do a Control Shift J, Control Shift J, Command Shift J. That is find and replace, and I will replace the B with a C, and I'll do a replace all, but within the selection. In selection, replace all. Okay. Now, if you would run all of these, here we have 5 in quotes, so it's a character. Only his character is true, all the other ones are false. Okay. Similarly, I would want to check for D. Okay, in selection, I would want to replace C with D. Replace all. Okay, so what do you have now? I had true. This should only be a logical. Okay, so it's not numeric, it's not an integer, not character, it's just a logical. Similarly, the next one, which is just F, should again be a logical, which is E. The variable is E, the value is F. Okay, so I will replace D with E. Okay, again within selection and all. Okay, so now all the D's are replaced with E. If I run, you would see it's a logical. Okay, so you can also write F instead of false, T instead of true, capital in capital, right? That is important. Okay, now the next one that we have is the square root of -1, which is not a number, but interestingly in R, even a not a number is a numeric data type. Okay, so it should come out to be numeric. Okay, so if I just check for F, okay, that is numeric is true, all the other ones are false. Okay, so that's how it works. And now finally I want to see square root of -1 plus 0 iota. As soon as I specify to R that it is complex by adding 0 iotas here, you would see that R would start taking it as a complex number. So if I check for G, right, again replacing F with G, okay, in selection replace all. Okay, so let's run this. So you would see it's is complex is true, everything else is false. Okay, so that is how it works. Now finally H, let's see H. Replacing G with H. Okay, so in selection replace all. Okay, and now let me run this. So you would see that it's come out to be is numeric. I intended to write something which was raw, but even though I've written it as a combination of zeros and ones, it has actually come out to be a numeric. Okay, so how do you actually write the raw data type? Let's talk about that. Although that's we won't be using that, but you should know how do you like type out the raw data type. So what you need to do is you need to use this function raw. Okay, so if you see G, I've assigned raw 5. So if you look at G, it's just a raw vector with the 5 zeros, right? They're all 0, 0, 0, 0. Now this, if you will check the type, it will be raw. So if you can, if you would check for G, I would also add an is raw here, is raw G, okay? And all the other ones, I will replace all the H's with G. Okay, so this would be G replaced with okay, H. Okay, no, not G. Let's make it I. Okay, so I'll replace all the H's with I. Yeah. Now you see. Now if I run this, you will see. Oh. So it's not a numeric, not an integer, not a character, not a logical, not a complex, but a raw. So that's how you write out raw numbers. There are other ways as well. You can do it through a vector, which we'll be discussing later. But for now, I've shown you how to write a raw data variable. You can't do it like this. Okay, that is what I just wanted to communicate. Now moving on. So this is your all of the data types and how to check them. There's also something called as data coercion, which means converting or forcing one data type into another, right? So how do you coerce data to become of another type? And then we'll also be talking about vectors a bit. Vectors are basically a container sort of a thing, right? They're a container of objects of all objects being of same data type, right? So all objects within a vector are of the same data type, right? You have studied vectors in math. These are similar. So they are basically a collection of various objects, but all of them have to be of the same data type, right? So before that, I just want to convert some of these existing objects into a different data type. Okay, so how do you do that? Okay, say you have the C, which is currently a string, okay, currently a character. I want to convert this into a numeric. Okay, so how do I do that? I would do this as numeric, and I will apply this to C, and I will store this in J. Okay, so J will be equal to as numeric C. So it will first convert C into a numeric and then store it in J. C had a value string 5 or character 5, it will just get converted to 5. So J now is a numeric 5, right? So if you check is numeric for J, you will get a true. But if we had earlier checked is numeric for C and that was false. Okay. So see, this is true. Okay, so that's how you can convert a character into a numeric. Similarly, you can convert a numeric or any other data type into a character. For example, if I want to convert D, which is true, into a character, so I would say K is equal to D and I want to convert it into a character. So as character, okay, and I will just run this. Okay, so that will be, you will see K is true in quotes. If you will check is character for K, you will get true. Okay, so that is how it works. You can convert these data types. You can make, if you remember your logicals, false is corresponding to 0 and true is corresponding to 1. So you can convert your logical into numeric and the other way around as well, right? So let me show you that. JKL, so L is equal to as character E. E was false, right? If I convert it into a character, it would become false in quotes. Okay. Now, if I want to convert it into numeric, it should become 0. Right. So it becomes 0. So if you will check is numeric L, that should give you true. Yeah, so that is how it works. You can convert it the other way around as well. If M I assign as 1 and you take N as equal to as logical M, this should become true. Okay, if I run both of them. So N should be true. So if you check N, that is true, and if you will check the is logical of it, that will be also be true, right? So is logical of N, that is also true. Okay, that's how it works. Next thing I want to discuss are vectors. Okay, so what are vectors? As I told you earlier, vectors are a collection of similarly typed objects. Okay, so let me show you. In fact, to create a vector, you have the syntax, which is C and then you put a bracket. So C 1 2 3 will create a vector with 3 values, and the values would be 1 2 and 3, and I want to assign this to X. Okay, so X is this now. Okay, so now you have X which has numbers 1 2 3. Similarly, you can create a vector with strings, right? So it can be hello world. This is a vector with 2 objects, hello and world, both are characters, right? So X has characters from 1 to 2, hello and world, right? So this is how your vectors always have similar type objects, right? All the objects within a vector have the same data type. Okay, now what happens if you put one number, one character and one logical into a vector? Okay, so let's say you put T, which is true. Okay, then R will convert all of these objects into the same data type, and usually it converts them into the easiest data type to convert anything into, which is the character data type. You can just put quotes around anything and make it the character data type. So that's what R will do, and once you run this, you will see you have a vector with 3 elements, 1, hello and true, and all of them now have been converted into character. Okay, so they were first read as what they are and then converted into character. It's basically same as applying as type. Okay, one important thing to note, that even your objects with a single value are treated as vectors of dimension 1 in R. Let me prove this to you. If you just take x or y is equal to c with 1, now this will be treated as a vector of dimension 1 and it will be same as the number 1. Okay, so if you'll see, y is just 1. Okay, if I would have let w equal to 1, and if I would have checked if w is equal to y, it will give me true. Okay, see, w is equal to y. So even singular objects, singular integer or float, which is double, or your boolean, which is logical, right, or a character, if you take them singularly, right, they are treated as a vector of dimension 1, right? So that is one important thing to note, right? Now let's talk about other collections that we have in R. Okay, now I want to discuss the fundamental object types or classes. Okay, so the first object that we discussed were variables, but as we discussed, variables were also vectors with just one data point within them. Okay, just one data point stored within them, but they were still vectors, right? So what are vectors generally? You can have multiple data points stored within a vector, but it's just a one-dimensional collection of data with the same type. That is the fundamental property of it. All the points of data that are within it should either all be characters, should all be numericals, should all be booleans. They can be anything, but they all have to be of the same type. That's the restriction. This is the most basic object in R, because even a variable is a vector of one data point, right? Then you have matrix. Okay, matrix, you've worked with matrix algebra. It's the same here as well. It's a two-dimensional collection of data. So there are rows and there are columns. And then as you increase the dimensions, you have arrays. Okay, these have more than 2 dimensions. So they are multi-dimensional collection of data of the same type. For vectors, matrix and array, the restriction is that within one vector or within one matrix or within one array, all the objects or all the data points have the same data type. Okay, but this restriction is loosened with data frames. Okay, data frames are like your Excel spreadsheets. Okay, you have two-dimensional objects where columns can be of different types. So you can have one column which is all numerical, maybe that's age. You can have one column which is all names, right? So that is all characters. Then you have one column which is saying whether the student has passed or failed. So that's true or false. That's a boolean, right? So you can have different data types between columns, but within one column the data type is the same. Okay, this is the most important type of object for data analysis, because this is like a spreadsheet in R, right? So within a column the data type is the same. That is the restriction. Then you have list. These are again one dimensional, just like vectors, but they can hold objects of different types and structures. Okay, so within a list you can also have a vector, you can also have a matrix, you can have another list itself, you can have a data frame, you can have anything within a list, right? Each object within a list can be anything. It can also be a single valued vector, which is just a variable, right? So it can be anything, right? So that's your list. And finally you have factor, which is a special type of vector which is used to represent categorical data. Okay, so the data is structured like levels which have limited numerical values. This is also something we'll discuss, but it's essentially used to discuss or represent categories of data. Okay, so maybe you can have small, medium, high, and that along that axis, different uh, you know uh, people have their marks are small, medium or high, right, or anything, right? You can have short heighted, medium heighted, very tall people, right? So anything which is categorical, right? You can have rankings from some person rating a particular ice cream, so they can rate it from 1 to 5, right? All of this is categorical data, so that can be represented using factors. Okay, so vectors are one dimensional, matrix are two dimensional, data frames are two dimensional, lists are one dimensional. Within vector and matrix, the data types are all the same. Data frame within a column, it's the same. Across columns, you can have different data types. Along a list, you can have different data types, and then you have various analogies for these. So just go through this table. So that is all about various collections of data or object types or classes in R. Right now, next thing I want to get into are particularly vectors. We'll talk about vectors in a lot of detail because they are the most basic type of objects in R, right? So vector is a one-dimensional ordered collection of data elements of the same type. They're ordered collection. Okay, that is important. That is, a vector 1, 2, 3, 4, 5 is different from 5, 4, 3, 2, 1, right? So the order matters. Even a single number like 5 is treated by R as a vector of length 1. This is something I've told you. Okay, the type here would obviously be numerical. Okay, how do you make a vector? You use C, which stands for concatenate or combine. So this is how you can make a numeric vector. This is something I've already shown you. Ages vector is made as C, 34, 28, 47. Or you can make a names vector, which is Bob, Larry, Ginger. You can make a smoker status vector, which is true, false, true. So this is all stuff that we have seen. You can also create sequences in R by using this colon sort of operation, right? So if I assign V1 as 1 to 10, right, what will I get? So V1 will get created as a vector, and it has integers from 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's how you can create a vector. Notice that this is integer and not just numerical or double, right? R has automatically created this sequence considering these integers, right? You also have another way to create sequences like these, which is by using the sequence function. Okay, so let's look at the sequence function. So let's assign V2 to SEQ. Okay, in fact, I'll just show you the help on sequence so that you understand a bit better. So SEQ. Okay, let's just get the help. So this is for sequence generation. You have a bunch of arguments that go in here. You have from to. Okay, so where do you want to start? Where do you want to end? What is the first number? What is the last number? Then by. Okay, by is basically 2 minus from. Okay, divided by length out minus 1. Okay, so let's just try and understand this. This is basically the size of every step. Okay, what is the gap in every step? So if I show you a sequence, to give you an example, I can have a sequence from 1 to 10 and the step can be 2. So the sequence is 1, 3, 5, 7, 9. Okay, the gap between each of them is 2. Okay, so that is your by. What is the gap between each individual element of the sequence, right? So that is your by. Then you have length out, which is what is the entire length of the sequence. Okay, if instead of this by, if I just wanted 8, sequence of size 8 here, what I could have done is I could have typed length out. Okay, and I could have said 8. Okay, now it will generate from 1 to 10 and the length of it would be 8. Okay, so your V2 now is 1, 2.29, 3.57, 4.86. Let me print it actually. So from 1 to 10, it has divided this entire interval such that there are 8 values here: 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So through length out, I can actually tell the length of the sequence, including both the starting point and the ending point, right? And you have along with actually generates a sequence which is of the same length as another vector. Okay, so instead of this, if I would have given it the argument along with, and I wanted to generate a sequence of the same length as v1, so I would do along with equal to v1. Okay, so now this will generate a sequence of size 10. Okay, so if I want to generate from 11 to 20, but the same length as v1, so it would generate again of the size 10. So from 11 to 20, it's 10 values, right? So the length of v1 and v2 is the same. That's what along with tells it. You have to generate a sequence which is of the same length as another vector. Okay, which vector I specify here. Okay, whenever you are writing an argument not in the given order, okay, and some of these arguments have default values, you need to specify which argument you are writing, because if I just would have given it v1 here, it would have treated it like the by argument, which is the third argument, but I want to write the fifth argument, so I'm writing along with here clearly to tell r which argument is it that I am giving it. Okay, so that is very, very important. uh, so that is something I just wanted to discuss with you. So that's how sequences work. Now in order to uh, test vectors, uh, you can actually or assess or understand what a vector contains. You have a bunch of these functions. Okay, let me make the length out as 8. Okay, so I have two different vectors. One is from one is from 1 to 10 of length 10, right? And one is from 11 to 20 of length 8. Okay, these two I have. So then using some of these functions, I can actually understand them. So the first function is length, which would return the length. So length of v2 should be 8. Okay, see, length of v1 should be 10. So that's how you check the length of a vector. Then you have class, which returns the data type of the elements in the vector. Okay, so if I do a class on v1, I should get numeric or integer in this case. So it's integer, right? Very, very specifically, it gives me integer. If I would make a v3, which has maybe I concatenate cow, dog, cat. So now it has all strings, right? So if I would check the class of v3, I would get character. Okay, so that is very, very important to understand. Okay, so this is how these two work. And then you have structure. Structure just gives you a compact summary of the vector, okay, or any other object, in fact. So structure of v3. Okay, so structure of v3 is is character with length 1, 2, 3, and it has cow, dog, cat. It is basically what is written here. It will just give you that same thing, right? In your in global environment object description, it will just give you the same thing, right? If I check the structure of v2, I will get the same thing which is mentioned here. So that is how your structure works. Okay, so all of these things we've seen. How do you name the elements of a vector? There are two ways to do it. Okay, one is if I want to name it directly while constructing the vector, so I can do it right like this. So I can call the cow as A2, right? Uh, Maybe I can start with A1, right? So the first animal is cow, A2 is dog, and A3 is cat. So this is how I can actually name while creating itself. Okay. So now I have V3, which has cow, dog, cat, but each one of these elements also has a name, A1, A2, A3. This is one way you can do it. Okay. Another way you can do it is by using the names function. So if you want to assign names to these values of v1 from 1 to 10, what you can do is names, okay, and you want to apply names to v1, and the names you want to apply are the number 1, number 2, number 3, number 4, right, so on and so forth, right. Actually, let me apply it to a shorter vector. So let me construct another vector. X is equal to uh, marks. Okay, marks I'll assign 33, 100, 55, 62. Okay, and then to this vector x, I want to assign the marks. So these are the marks of Ram, Sham, Victor, and David. David. Okay, so the names which are assigned to X are these. So this is also how you can assign names. This is one way to do it. Another way to do it is this. Okay. So now again, X has 3300, 55, 62, but the names are also stored as Ram, Sham, Victor, David. Okay. Now, how do you refer to specific elements within a vector? Okay, that's the question. So let's say I want to get the fifth element of v1. Okay, I have these four vectors, I'll be working with them. Let's say I want to get the fifth element of v1. Fifth element of v1. Okay, so I'll do v1 and 5. Okay, so that will be 5. The fifth element of v1 is 5. If I want to get the fifth element of v3, v3 doesn't have 5 element. Let's say I want to get the second element of v3. Okay, so I will just do v3 2. Okay, the second element of v3, that will be dog. So that is correct, right? So that's one way you can fetch these elements. Another way you can fetch these elements is by calling their names. Okay, so how do you do it using names? So you would say from X, I want to fetch the score of Victor. Okay, so this is also how you can refer to it. It's 55. The score of Victor is 55, right? That's the third one, right? So you can either refer through the index. This is called as the index. At what index is that particular value? Or second way to refer to it as is through its name. So that's another way. If you want to select a bunch of values from a particular vector, let's say from v2, I want to get from 2 to 5th element. Okay, I want to get from 2 to 5 element of v2. So that is starting at second, ending at fifth, right? So second, third, fourth, and fifth. Okay, so if you see, the second element is indeed 12.3. The exact value has come. Okay, so you can also refer to it like this. Okay, so this is the score of Victor, and this is the element 2 to 5 of v2. Okay, so that's how you fetch them. You can also fetch elements this way. Another way to do it is v2 and then I do a C2 to 5, C2 comma 5. Okay, you can also do this. This would get you the second and the fifth element. Okay, this was 2 to 5. If I want to get element, second and the fifth element. Second and fifth element. What am I telling it? I am giving you the indexes of the elements that I need, and in order to give you the indexes, I will first create a vector of those indexes and then provide you and tell you to fetch it from V2. So that's how it works. Because even when I was giving it this, I was giving it a vector with just one value. Here I'm giving a vector with two values, 2 and 5. Okay, so now I want to get these two, second and fifth value. So second value has come and fifth value has come. So this also works. If you want to exclude some elements, you want to get all the elements except some, you can also do that. So if you want to get all the elements except the elements which are from 2 to 5, you can put a minus sign in front of them. Let's see if this works. Yes, it does. So get all elements except 2 to 5. So it would have given me elements 1, then 6, 7, 8. Okay, so there are a total of 8 elements except for 2 to 5. These are the elements. If I want to get elements other than 2 and second and fifth element, so I will just put a minus in front of this. Okay, so that's also something you can do. So you see all the elements have come, but the second and the sixth element, this and this are excluded. Okay, so that's also what you can do. You can also apply logical filters on vectors. So let's say I want to fetch everyone's marks whose marks is greater than 50, right? Greater than 50. So x, within x I want to fetch the cases where the marks are greater than 50. So x is greater than 50. That is my condition, right? So I get 3 students, Sham, Victor and David, and their marks are greater than 50, right? If the passing criteria changes to 60, I want to see who's greater than 60. That's Sham and David. Okay, so that is also how you can work with filtering vectors based on logical criteria. Okay, so now that is fine. Now let's get into vectorized arithmetic, right? What happens if I have this vector v1 from 1 to 10 and I add 3 to it? Okay, so what is v1 plus 3? So each element of v gets 3 added to it. So 1 plus 3 is 4, 2 plus 3 is 5. So when you add a constant to a vector, right, you add that constant to every number in that vector. That's the first thing, right? Second thing is, what happens if you multiply a vector with a number, right? Let's say you multiply v1 with 2. So each element gets multiplied with 2. Similarly, if you divide v1 by 2, each element will get divided by 2. Okay? Subtraction also works the same way. See? Okay, so that's how you can work with a vector and a scalar essentially, right? Next is, how do you work with a vector and another vector? Okay, so let's say I would do v1 and I have another vector of the same size. Okay, so let's call that vector v4. Okay, let's say v4 is 10 to 100. Okay, but I want to have a space of 10, so that would be by equal to 10. Okay, So that will be 11 elements, right? Let me do a length out and say 10. So 10. No, this is fine by 10. This is fine. This is still a vector of length 10 only. Okay. So you have V4, which is 10 to 100, which is 10 elements, right? So V1 and V4 have the same length. So what happens if I do V1 plus V4? Okay, if I add them up, so individual elements of V1 and V4 get added, right? So 10 plus 1 is 11, 20 plus 2 is 22, 30 plus 3 is 33, 40 plus 4 is 44, and all the way up till 100 plus 10 is 110, right? So that is how it works. Now what happens if I multiply them? So V1 times V4, right? Then individual elements would get multiplied. So 1 times 10 is 10, right? 2 times 20 is 40, 3 times 30 is 90, 4 times 40 is 160, and the last term you get 10 times 100 is 1000. Okay, so each element is getting multiplied. But what happens if you multiply vectors of unequal length, or you add vectors of unequal length? Then there is something in R which is referred to as recycling rule. Okay, let's understand the recycling rule. So V1 plus V2, right? V2 is length 8, V1 is length 10, right? So what R will do is, for V2, it will repeat the first and the second elements of V2 to complete it, right? So V2 will essentially become, if I print V2, okay, let me show you. So V2 starts from 11 and goes all the way up till 20, right? The length is 8, but in order to add it to a vector of length 10, R will repeat 11 and 12.28571 at the end to forcefully make it a vector of length 10. Okay, so it will become a vector with 11, 12.28571 all the way up till 20, then 11, and then 12.28571. Okay, it will repeat it so that it can add them up. And then now if I add them up, okay, if you print V1 and V2 separately, you will realize that V1 plus V2 is exactly the sum of these for the first 8 elements, right? So 11 plus 1 is 12. 12.28571 plus 2 is 14.28571. Then your 13.57143 plus 3 is 16.57143, right? So on and so forth, right? Up until the 8th element, which is 20 plus 8, which is 28, right? So this is all fine. But for the last 2 elements, what you would notice is that the second last element is just equal to the second last element of V1, which is 9, right? Plus the first element. It has repeated V2, right? Because it has run out of elements. After the 8th element, the 9th element is not there, so it just uses 11. 11 plus 9 is 20, right? For the last element, it is 10 plus 12.28571. It has repeated this element, so it is 22.28571. So this is the property of recycling, right? R just repeats the elements of the shorter vector in order to get you the answer, right? When you add a longer vector to a shorter vector, and the same thing will happen when you multiply these two vectors. Okay, it also gives you this warning message that in V1 plus V2, longer object length is not a multiple of the shorter object length. So the second vector, which is shorter, only the 8 elements of it are used, and then the first 2 elements of it are used. Not all elements are used equal number of times, and that's why this error comes in, right? So that is the idea. Now, with this knowledge, let's just get into this puzzle that I want to discuss with you guys. Okay, so let's start with this. It says in statistics, an outlier is often defined as a data point that falls more than 1.5 times the interquartile range above the third quartile or below the first quartile. Okay, so what are they trying to say? Firstly, what is their definition of the outlier? Let me just explain that to you first, and then we can get into the calculations with the given data. Okay, yeah. So if you see, what they're saying is, look, from in your data, you calculate your first and third quartile. So you calculate your Q1 and Q3. Okay, and the interquartile range is equal to Q3 minus Q1. Okay, this is your definition of the interquartile range. They are saying you will call any number as an outlier if you take your Q3 and you even look further beyond this and you add 1.5 times the interquartile range to it. Okay, so this will be a number further away, Q3 plus IQR times 1.5, right? And you will calculate another measure which will be Q1 minus IQR times 1.5, or you can say 1.5 times IQR, right? If any number is to the left of this or to the right of this, it will be called as an outlier, right? It's so far away from Q3 that it's more than 1.5 times the interquartile range, further away from Q3. Or it's so far away from Q1 that it's more than 1.5 times the interquartile range away from Q1. Then we will say this value seems like an outlier, because 50% of the data is located here and only 25% of the data is located here, and even in this area I'm going really far away, right? So the point that I get to is really an outlier point, right? So you first need to calculate Q3 and Q1, you need to calculate the interquartile range, and then you need to see what values are greater than Q3 plus 1.5 times interquartile range, and what values are less than Q1 minus 1.5 times interquartile range. Okay, that's the goal. So they are saying that you have been given the data in the following vector, right, which is this is your data vector. Write an R script that calculates the first quartile and third quartile, calculates the interquartile range, defines the upper and lower bound for the outlier detection, okay, which is Q1 minus 1.5 IQR and Q3 plus 1.5 IQR, and create a new vector named outliers that contains only the values from the original data vector that are considered as outliers. Okay, so let's start this, and I want to work on a new R script. Okay, it's a new file R script. Okay, my working directory still stays the same. So if you see get wd, your working directory is still the same. Okay, but I've created a new script and I want to call this as outlier computation. Okay, so that's what I'm doing, and now I just want to start writing my code. So the first thing I want to get is get the quartiles. So in order to get the quartiles, there's a function called as quantiles that you need to use. Quantile basically is any positional measure from the data is called as the quantile. It can be a percentile, it can be a median, it can be a quartile, right? So firstly, let's just try and understand quantiles. So what I'll do is I'll do a question mark. Maybe it's quantile and not quantiles. Yeah, quantile, right? So using quantile, you can actually put in x, which is the numeric vector. So the first argument it takes is the vector, and the second one it takes is the probability, right? At what positional value do you want this quantile, right? So q1 will be at 0.25 and q3 would be at 0.75, right? So that is how it works. So I'll use quantile, but before that let's just get the data. So this is my data vector, right? So defining data, and that's my data. Now quantile can be calculated as q1 will be equal to, I can clear all of my information before this, right? Quantile add data, right? And I want to get the 25th percent value. So that is my Q1. Let's run this. So if I run the whole thing, yes, Q1 is 28.2, and similarly you can define your Q3, which would be quantile data at 0.75. Okay, this would be your Q3, right? So your Q1 and Q3 are defined like this. You could have also used an alternative measure, which would have been quartiles could have been directly defined using the quantile function. Both the quartiles could have been defined. How would you do that? You would take data and you would put both the probabilities at which you want the quantile, because this probs takes the numeric vector of probabilities with values in 0 to 1, right? So you can put multiple values here. You can take multiple values here, right? You could have directly gotten the 25th percentile and the 75th percentile, which is Q3 and Q1, right? So you could have done this as well. Again, this just gives you quartiles directly. So either or both the definitions are fine. You could have just combined these two and defined quartile like this, right? So here as well, quartiles could have been C, Q1, Q3. Okay. Both of the methods, this with 3 lines of code gives you this quartile, and this with 1 line of code gives you the same quartile, right? So in RU, if you are if you have better understanding, you'll be more efficient, right? That's the only difference. So that is one thing. So alternatively, okay, so this is how you get your quartiles. Now once you have your quartiles, what you can do with these is you can get your interquartile range. So again, there are two ways to get the IQR. Okay, the first way is Q3 minus Q1. Okay, that's the first way to do it. You can also write IQR as quartiles to the second element minus, if you would have just made it this way, you wouldn't have Q1 Q3, so you could just do quartiles 2 minus quartiles 1, right? Again, the value will not change. You will notice it's still the same, right? Another way to define the interquartile range is a formula called as IQR. So IQR, right? I'll show you this. This just gives you the interquartile range directly. Okay, you just need to put in the vector. So how would you do this? It would just be equal to IQR, and then you would just put in the vector x, which is the data. Okay, again your IQR is 9, and this way also your IQR is coming out to be 9. Doesn't change, the IQR is still the same. Okay, so no matter how you calculate, this IQR comes out to be the same. Now you will compute your definition for outliers. Okay, so outlier threshold, or actually what I can do is I can directly get the outliers. Let's see how I do that. So outliers would be equal to data. Within data, I would filter where data is I would filter to data where data is greater than Q3 plus 1.5 IQR, or data is less than Q1 minus 1.5 IQR. So you can do this directly. This is the OR symbol in R. Okay, remember this. If you are filtering something, AND would be this and OR would be this. Okay, So these are your and or symbols. This or you can type as just shift plus the key which is under the delete key, which is the backslash key. If you press that, you get your or symbol, which is this one, right? So yeah, with this, what I'm saying is within data, filter to the values of data where data is either greater than Q3 plus 1.55 QR or less than Q1 minus 1.55 QR. Once I do this, I will get my outliers. Oh, Q3 and Q1, oh, they're case sensitive. So Q3 and Q1 need to be like this. Okay, so that's your outliers. So outliers come out to be 55 and 78. You can just print outliers. You can print everything. So let me concatenate everything in print. You use the command cat to concatenate strings to merge strings together. How do you use it here? Let me show you. So you want to print all the results. So the first thing I want to print is Q1 equal to, okay, then the value for Q1. So the first string is this, and then this gets joined with Q1, comma, I want to print Q3 equal to, this is another string I want to print, and I want to print Q3. Then I want to print IQR equal to, okay, and then I want to print the value of IQR, the object IQR, which is here. And then finally, I want to print the outliers string and then the outliers vector. Okay, so if you run this, you will get all your answers. Q1 is this, Q3 is this, IQR is this, and outliers is this, 58, 78. Okay, so yeah, that's how you can print everything, all your results together. In fact, you don't even need this print command around it. You can just write cat and just do this. Okay, so this just gives you all of your results. Okay, so that's how it works. That's for this question. So let me just say defining outliers and printing result. Okay, so that's all. We'll just save this script. Okay, thank you.